Hello, I'm Seema and welcome to part 21 of the chapter Solutions. We have been discussing colligative properties and I told you that there are four colligative properties. The first is the relative lowering of vapor pressure, second is the elevation in boiling point, third is depression in freezing point, and the fourth is osmotic pressure. In the past few videos, I have discussed the first three colligative properties in detail. It is now time to discuss the fourth colligative property, that is osmotic pressure. But before I actually come to the colligative property, that is osmotic pressure, I would like to use this one video to explain what osmosis is and why is it so significant? Why is it so important? So let us first study about osmosis. So you could say, in a way, the topic of this video is osmosis. If you take grapes, that is grapes, and you dry them out in air, on air drying grapes you get raisins. Don't you get raisins? Right? Raisins are often used because they can be stored dry. They are dehydrated grapes, and therefore their shelf life really increases because they can now, the bacteria need a medium to work on, and that medium is not available. If you keep them in an airtight container, they can last a long time. But have you noticed, if we take these grapes and we put them in water, what happens? If we take these raisins and we put them in water, what happens? I did that last night for you. I took a few raisins and I put them in water. Do you see? They seem to have ballooned up and turned back into the grapes they were turned raisins from. Do you see? Yeah, they seem to have ballooned and they seem to have formed the grapes from which they had come. So what happened when they lost the water? They resulted in the formation of raisins, and when they gained back the water, they turned back into grapes. But there was no tap, there was no hole from which the water escaped or entered. Or was there a hole or more holes that we did not know of? The cover of the grape, that is, if you can peel off the cover of a grape, you can see the peel is actually it's like any peel of the eggs. Inside the eggshell you see a membrane. That membrane, this peel is like a membrane, and this membrane has tiny pores in it. It has tiny holes in it. These pores are extremely small. And what is wonderful is that through these pores, the water can go in, the water can come out. Like when we left the grapes to be air dried, the water evaporated and it resulted in the form of raisins. And when we put the raisins in water, through the same membrane, the water went in and it absorbed the water through the pores present in the membrane, and it swelled up to give you back the grape. But what did not happen was, even when we were sun drying the grapes, the content of the grapes, the sugar and whatever other content was there, did not escape. It was only water which went out. And when we put it in water, again, it is only water that is going in. Nothing is coming out from the grape. Which means that whatever this cover was, or this membrane is, this membrane allows certain particles to pass through it and does not allow other particles to pass through it. It's not really very difficult to understand. If you have a sieve and you have, let us say, pieces of sand with some pebbles also. You have sand and some pebbles and you start sifting it. And when you start sifting it, what do you see? When you sift it, the small sand particles can pass through the sieve. The sand particles which are smaller than the size of the holes in the sieve. But the small pebbles, which are actually larger than the size of the sieve, they remain in the sieve and you cannot remove them. So you can just sift out the larger particles from the smaller particles through the sieve. It is somehow the same thing but at a microscopic level. These membranes are like the sieve. They allow certain molecules to enter and leave, but they do not allow other molecules to enter or leave, maybe because those other molecules may be larger in size and therefore they can't escape. And since they can't escape, if you had them outside also, they couldn't enter. Such a membrane which only allows certain particles to pass through them is known as a semi-permeable membrane. A membrane that only allows certain particles to pass through it, and maybe because of the size, and usually we see when we talk of osmosis, it is the solvent particles which it allows, and it does not allow the solute particles to pass through it. But a semi-permeable membrane would be a membrane which allows certain particles to pass through it and does not allow other particles to pass through it. Now, these semi-permeable membranes can be natural, or they can occur in nature, or they can be synthetically prepared. The ones that occur in nature are like parchment, they are like the cellular walls, like the cover of the grapes. And the eggshell, inside the eggshell, that membrane that you have, that is also natural. Pig bladder is a natural semi-permeable membrane. So you can have many semi-permeable membranes, some of which would be of natural origin and some of which would maybe can be artificially prepared. Now that you understand what semi-permeable membranes are, let us come to what osmosis is. This process of only the solvent molecules moving through a semi-permeable membrane. This process of the molecules of the solvent moving through a semi-permeable membrane is known as osmosis. That process is basically known as osmosis. But the question is, in which direction do these molecules flow? Do they go inside? Like, how would you know whether the water is entering the grapes or is water leaving the grapes? Is it entering the membrane? Under what condition did water enter the membrane? And under what condition is the osmosis taking place outside the thing? Now, when osmosis is taking place outside the body, in this case it was the grape, we'll call it exosmosis. It is occurring outside, it is going out. And when osmosis is taking place inside the particle or the body, we call it endosmosis. So when you formed raisins, the process responsible for the formation of raisins was evaporation of water present inside the grapes, which escaped through the semi-permeable membrane. So it moved out of the grape. So it was it was exiting. So exosmosis caused the formation of grapes. But when we took the raisins and we put them in water, the water now entered back into the raisins to result in the formation of the same grapes. And that process is endosmosis, because now the osmosis is taking place inside. So how would you complete the definition of osmosis is that osmosis can take place towards the outside or towards the inside, and it's a spontaneous process. It occurs on its own. I did not have to force the water out, or I did not have to force the water into the raisins. Since it's a spontaneous process, what decides the direction of flow? The direction of the flow of the solvent is always from its higher concentration to its lower concentration. So that part of if there are two sides to a semi-permeable membrane, let us say this is inside the grape and this side is outside the grape. If the concentration of the solution inside the grape is high, or if the solvent is less, concentration of the solute will be high when in ratio the solvent is less. And on this side, the solvent is high and solute is less. Only the solvent moves. Now the solvent will move from its higher concentration or from the solution of lower concentration towards that side which has less solvent. So the solvent always moves in the direction of less solvent. Wherever you have more solvent, the solvent will move to that other direction through the semi-permeable membrane, and this process will continue till an equilibrium is established. And no more, it is dynamic, of course, that molecules going in are equal to the molecules coming out, but at this point you find that no more, the concentration does not change, and the concentration of both inside and outside or across the semi-permeable membrane on both sides, when the concentration becomes equal, that is when osmosis stops. So let us read the definition of osmosis. The process of flow of solvent through a semi-permeable membrane from low concentration. Low concentration means the solution has low concentration. which means the solvent is more. When does a solution have low concentration? When solute is less. If solute is less and both of them have the same volume, then it means the solvent is more. So from low concentration of the solution to high concentration is called osmosis. I just explained to you what a semi-permeable membrane is. Here's an example or an experiment. If you take a thistle funnel is a funnel and you invert the thistle funnel. It's a funnel with a long tube, is known as a thistle funnel, a glass funnel. So when you put it inside a solution, and what do? You have the mouth of the thistle funnel has been covered by a semi-permeable membrane. And we dip it into a solvent, and inside the thistle funnel we have a solution. Let us say we have water in the beaker, and inside the thistle funnel we have a little salt in water. Now the concentration of the solution inside the thistle funnel is high, and the concentration of the solvent, of course, the solution, if you call it the solution, then the concentration outside is less. Or in terms of solvent, the concentration of solvent is more outside and less on the inside. So now when you dip this and through the semi-permeable membrane, where do you think the solvent will flow? Will it flow from the thistle funnel to the solvent, or will the solvent start entering the thistle funnel? What will happen logically? Inside the thistle funnel, some of the volume is occupied by the solute particles. So the concentration of solvent is less. Therefore, the solvent is more here, so the solvent will start entering into the thistle funnel till the concentration of the solvent in both the outside and inside the thistle funnel becomes equal. The level of the liquid in the thistle funnel will start raising, it will start increasing till the concentrations on the inside and the outside, they become equal and an equilibrium is established. So now let us repeat what the definition is to understand this. The process of flow of solvent. Solvent moved through the semi-permeable membrane which was present, and from the low concentration, the solvent which was present has almost zero concentration of solution if you really look. There is no solute in it. From low concentration to high concentration of the solution. When we talk of low concentration, high concentration, we are talking of the solution. If we talked in terms of only solvent, we would say from high concentration of solvent to low concentration of solvent. But just to make it easier, since your textbook refers to it only as solution, so we will say it always moves from low concentration to high concentration. A semi-permeable membrane, the abbreviation used for semi-permeable membrane is SPM, is placed between the solvent and the solution. The semi-permeable membrane is placed between them, and the solvent molecules move through it to the solution till equilibrium is established. The solvent molecules keep entering it inside the solution till the equilibrium is established between the solvent and the solution. If we take a few examples of osmosis in real life. Raw mangoes, we do pickling of mangoes. We make mango pickles in the summer because mangoes are abundant in the summer. And in India, it's a common practice to make pickles for the whole year in the summer. So you take raw mangoes and you put a lot of salt on them. And when you put a lot of salt, what happens? The presence of salt makes the concentration, and there is moisture in the air. So the salt, if you ever leave salt out in the open, it kind of becomes wet, and the reason is that it absorbs the moisture from the air and it turns wet. So if it can absorb the moisture from the air, if you put salt over the mango, what will happen? The amount of water inside, the solvent present inside the mango, that will start moving out. That is the water, it starts moving out and the salt attracts it towards itself, and therefore osmosis occurs. And which osmosis? Exosmosis. It is moving out. And when all the water comes out, the mango, it shrivels, it becomes smaller in size. And you could have raw mangoes in brine. That is, brine is nothing but a concentrated solution of common salt. When you put that and you put raw mangoes into it, the mangoes, they shrivel and they get pickled. And raw mangoes, they shrivel and when they are pickled in brine. And even if you do not use brine, you just put a lot of salt on them, the water from the atmosphere itself will turn it into brine, and it will start absorbing all the moisture from inside the mango. Now there's a question. Why does a substance which has been pickled, why does it stay? It has a longer shelf value. If you just kept raw mangoes because they taste good, would you be able to save them for the whole year? But a pickle would last till the next summer. What is the reason that these pickles, they last for so long? There is bacteria which is always present. So why doesn't the bacteria spoil the food, spoil the mangoes which have been pickled? The reason is that the bacteria which is present, that is also exposed to that much of salt. And as a result of which, the liquid, that is the solvent present inside the bacteria, is also sucked out. It is also removed by osmosis. And as a result of which, the bacteria is present, but it collapses, it dies by losing all its solvent. It is as if, imagine if blood was sucked out of your body completely, what would happen? It is almost similar to that all of the solvent is automatically removed, and therefore the bacteria, they are killed. And that's the reason why pickled food does not get spoiled easily. So that was pickling and how osmosis is important here. Another example is wilted flowers or wilted plants. Do you know, if I sometimes forget to water my plants at the right time, I find that their leaves, they wilt. Especially, I have this fern here, the frosty fern. The leaves of the frosty fern, they'll just fall down. They'll be so sad if I don't water them. But if you water them like I watered them just last night, they are perky in the morning. They just perk up. They're happy. Why? Because the water that was put into the soil was absorbed through the roots, and it went up, and it went up the tissue. How? It went up through the process of osmosis. After all, the plant has walls around it, and those membranes are semi-permeable membranes. So this is an example. Another plant I'd like to show you is this ivy that I have here. Take a look. Such perky leaves. If you water them, they are happy, they perk up, but if you do not water them, they'll be limp, they'll fall down. So the flowers and plants, they perk up when you add water to them. So wilted flowers, they will be revived if you add water to them. Not only wilted flowers, have you noticed when you go to the fresh vegetable or fresh produce market, you find the vendor there, he's usually splashing water over the vegetables and the fruit. Why does he splash water over them? Because there also, due to exosmosis, the water may just evaporate and it will not look that fresh, and the fruit and the vegetable may go limp. So they keep splashing water over it. Even coriander leaves, if you see, they keep splashing water over it so that it remains perky. Then the wilted flowers, they revive when you place them in water. Raisins swell up in water. I showed you this example that I put these raisins in water and they swelled up to give you almost grapes. So raisins, this also occurs due to osmosis. The membrane outside is semi-permeable and it absorbs the solvent, that is water. Another very, very important aspect of or utility of our knowledge of osmosis is in medicine. Blood cells, they have a certain concentration, and blood cells are very important for survival. So if you put blood cells in saline water, the salinity of the water will cause exosmosis, just as pickling takes place. In a way, you're kind of pickling the blood cells. If you put blood cells into saline water, they would lose the water by exosmosis and the blood cells would collapse, just as bacterium did. So they would collapse. The percentage or the concentration of blood is 0.9% sodium chloride solution. If you put it in 0.9% sodium chloride solution, the concentration of the solvent in both the blood cell and outside is equal. And when the concentration of both the solvent, the solution outside and inside are equal, at that time osmosis does not occur, because osmosis is a process which is a balancing process. It will only occur. Now, for example, there are two bodies at different temperature. The body which is colder, the body which is warmer will transfer the heat to the body which is colder, and this will continue till both the temperatures become equal. So it is a kind of a balancing act. The same thing happens if the solvent is less on some place, the solvent starts moving in that direction where the solvent is less until a balance is maintained. But if we had two bodies which were at the same temperature, do you think they would transfer heat? Would A transfer heat to B or B transfer heat to A? There is no reason to do it. Therefore, when you have two substances which have the same concentration, osmosis does not occur. The transfer of solvent molecules may be taking place, but the concentrations remain the same. So neither would they shrivel nor would they swell up. Neither would the tissue shrivel nor would it swell up. So that is what we want. We don't want blood cells to shrivel and die. We don't want them to swell up and burst. So both the things are what we don't want. We want them to be as they are, healthy, same size. That is possible if we put them in a solution that is 0.9% sodium chloride solution, has the same concentration as those of blood cells. So if the concentration of the saline solution is increased beyond 0.9%, when we say 0.9%, we are talking in terms of concentration of mass per unit per volume, mass over volume percentage. The different ways in which we report concentrations, I would suggest you watch that video if you don't understand that. It is the mass of the solute upon volume of the solvent into 100. That is the mass over volume percentage. So mass over volume percentage of 0.9%, if you have that concentration of solution, then the blood cells do not collapse. But if it is higher than that, then the water from the blood will start moving, blood cell will start moving out, and the blood cell will collapse. And if this solution in which we put the blood cell has concentration less than 0.9%, then it means the concentration of the solution inside the blood cell is higher, and therefore the solvent will move from outside to inside the blood cell, which may cause it to swell up. It may even, and if the difference is too much, it may even burst. The blood cell may burst, so they swell up. What happens to people who have too much of salt, when you eat too much of salt in your food, we find that those people, they start retaining water. Doctors call the condition that they are retaining water is called water retention. They have water retention in their tissues. What does that mean? When you consume a lot of salt, the food that you have, that is digested and it is absorbed, assimilated, and all that food is transferred to the tissue of your body. Every cell of your body gets that food. And when it gets that food, if you ate salt, that salt also goes into the entire tissue. Now, every cell is covered by a semi-permeable membrane, and the fluids in the body that are moving around, their concentration and the concentration of the cell, it becomes different. The concentration of the cell increases and the concentration outside is less, and therefore the solvent starts moving into the cell. The water which is present in the body fluids, that starts getting absorbed by the cell, so that the concentration becomes equal by end osmosis. As a result of which, what happens? The cells, they swell up. And when they swell up, the person looks really swelled up, and that condition is said to be edema, that the person has edema or they have got water retention in their body. So that's the reason why doctors always ask you to have a low sodium diet, so that such a condition is not created in the body where your tissue, it starts swelling up, or the cells, they start swelling up due to osmosis. Another example is carrots, or I told you the vegetable, any vegetable. Carrots also, if you leave them out for some time, for a few days, they get limp. And when you put them back in water, after a little while, you find the carrots become nice and crisp and hard again. The reason for it is when you place them in water, the tissue that had lost the water to the atmosphere by osmosis, it absorbs the water back by end osmosis, and the carrots are nice and fresh again. And what I told you, that water from the soil, it rises in a plant. It rises in a way through the xylem by the process of osmosis. the roots of the plant, every tissue, every cell of the plant has got a cellular membrane which is semi-permeable in nature. We water the soil, the water passes through the semi-permeable membrane, and the process, like one cell in contact with the next cell, they both have different concentration. So this has more solvent, so the solvent moves up. Again, now this has more solvent, the cell above it has less solvent, so the water moves up. So in addition to transpiration, which occurs where the sun is pulling the water from the leaves and the water from the roots, a chain reaction of two processes takes place. Transpiration, the sun heats up the water, it evaporates it from the leaf. And when the leaf loses water, a deficit is created. That cell wants water. It takes water from the cell under it. That takes water from the cell under it. That takes from under it. And the last cell, it absorbs the water from the soil. And that is how a chain or a method of absorbing water right from the bottom of the root to the tip of the plant is maintained. That is how it is done. So you see how important osmosis is in nature or even in medicine, in life. So this was osmosis, and this is all about osmosis. In the next video, I'll tell you about the fourth colligative property, that is osmotic pressure. If you found my video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.